course, one of the most important aspects about non-caloric sweeteners is that they do not affect blood glucose levels, as do some of the caloric sweeteners, sucrose and so on. So that is, of course, why they are very important for management of diabetes. They are also low in calories, and they achieve this function of being low in calories through two different ways. One, as I will show you for each of the different sweetener I'm going to talk about, they are much sweeter than sugar. So although they may gram for gram contain the same number of calories, we use so much less that the calories become very insignificant. The other approach, and what you'll see for some of the sweeteners, is that we do not absorb them. So because they do not even enter our body, we cannot obtain any calories from them. So there's quite a number of non-caloric sweeteners that are approved for use in Argentina. I'm going to focus primarily on 4 that are prominently used. The first 2, a sulfame K or a sulfame potassium, is often blended with aspartame. So I'll talk about those 2. Stevia extracts, or stevia glycosides, as I'll explain as we go along, is one of the newer ingredients on the marketplace. And lastly, sucralose is also used in a number of food and beverages in Argentina. Sucralose then. Sucralose is one of the sweetest sweeteners that is in the marketplace. It is 600 times as sweet as sugar, so very powerful sweetener. It is very interesting because this actually is very similar to the structure of sugar itself. What is different is that if you look at those green molecules, those chlorine molecules, in sugar, those would also be the hydroxyl or OH groups. So it is that change just of those 3 molecules that dramatically affects the sweetness of that compound, which I think is quite fascinating. Sucralose is not only is it incredibly sweet, so you do not need very much of it, it also is poorly absorbed. So most of it, about 85%, just simply goes right through and is out in the feces. So there is no absorption or intake into the body at all. When it goes through the feces, of course, there is the opportunity for the gut microflora to act on that compound, which is important, as you'll see for the next sweetener. However, for stevia, it does not affect the structure at all, and it simply is excreted without any change. There is that small amount, and of course it's very tiny amount that is entering the blood because it's only 1/600th of the amount of sugar, and then you divide that, of that 1/600th, only 10 to 15% is actually entering the body. So we're talking teeny amounts here. And it is not metabolized. It simply, again, goes out through the urine. A very small amount can be changed somewhat by the liver through a glucuronidation process, and then it will also be excreted in the urine. The last sweetener I want to talk about in terms of how the body uses it is the stevia extracts. These have been, are new into the marketplace. There's a fair bit of interest in them because they are from a natural source, and that is very appealing to many people. They are purified from the leaves of a South American shrub called Stevia rubiania. I don't know if I pronounced that with the right accent for here. The sweetness in this plant comes from some very complex molecules. And when you look at them and think, how does that, compared to sugar, how does that interact with our taste receptors and actually cause sweetness, is quite interesting. But it is this very complex structure called steviol glycosides, and there's a variety of them in stevia. Riboside A, this one I'm showing you here, is one that's often there in the highest concentrations. The reason they're called glycosides is because they contain these glucose molecules. And the different glycosides differ from each other by how many glucoses and where on that backbone those glucoses are attached. When they are purified down to the pure glycosides, they are approximately 200 to 300 times as sweet as sugar, depending on which specific glycoside we're talking about. So these are, as I said, very large molecules. They are not digested in the small intestine, and they are not absorbed. What happens is once they enter into the colon, then we have very active enzymes from those microbes that can cut off or cleave off those glucose molecules. What happens is for all of the different stevioglycosides follow exactly the same pattern, and all of them end up in the large intestine as steviol with just hydrogen formed at those groups and no glucoses. So this is a smaller molecule. It actually is absorbed now into the large intestine. It undergoes some modification by the liver, and then it is excreted. For food additives, this is done through very extensive studies. It is required that at least 3 different species are tested. Usually it's the rat, the mouse, sometimes the dog, sometimes a rabbit, sometimes a hamster, at least 3 species. So we really understand how a body, a mammal, is going to use it. There's often criticism over the fact that, well, we use such high doses in these studies that it's not really realistic. That is absolutely true. It is not realistic. And the reason that we use those high doses is to increase the probability that we are going to be able to detect any adverse effect. Because if you have it at just a low level, you're going to have to test so many animals in order to be able to detect an effect. So we have it very high to be able to understand, is there going to be any effect? Then we use mid and lower levels to really establish, okay, at what dose is that effect not going to happen? And that's going to be our safe dose. The guidelines for setting these testing methods are internationally accepted. This is universally. We've just done a review of different international regulations, and pretty much in every country uses very similar guidelines that have been set up by the Joint Expert Committee of Food Additives, or JECFA. It's established from WHO. There is another also establishment, OECD, which also has specific guidelines for toxicology testing. So from there, we're going to do the estimate of the acceptable daily intake. This is the amount that is defined as what we can eat every day for our lifetime without a health effect. So we use that no observed effect level that caused no changes in the animals. You use the most sensitive species, then you divide that by 100 to take into account the fact that there are differences, there may be differences between humans and animals, or differences between individuals. So then you divide that by your safety factor. So for example, in your animal study, you had no effects shown at 4,000 milligrams per kilogram body weight per day. Then the acceptable daily intake will be set at 40. So what that means is it's very conservative. We're starting from the amount that has no effect over a lifetime, and then reducing it by at least 100. So let's look at the different sweeteners. And I'm just going to go through these very quickly, and I'm happy to share my slides with any of you if you would like that. So for ACE-K, the ADI is upwards to 15 milligrams per kilogram body weight. So this was set, of course, initially by ensuring the amount added to foods would not exceed that. But there is subsequently continual review of the marketplace to ensure that in different countries, different uses, we are not exceeding that acceptable daily intake. So you can see that it's studied in Australia, Canada, France, many different countries. And consistently, we are using a very small amount of acesulfame K compared to the acceptable daily intake. And there is no report that users are exceeding that level. Even the high users, the diabetics, the ones that are using these all the time, those are the ones we are most interested in. So aspartame, of course, is widely used. It has acceptable daily intake upwards of 40 milligrams. It is probably one of the most widely studied in terms of consumption, and it is one where we do have a survey from South America. And again, the levels are quite low, upwards on average around 4 to 5 milligrams, or about 10% of the acceptable daily intake. Those highest users, not even half of the daily intake. So same story. For the stevia extracts, the acceptable daily intake is based on that backbone steviol equivalent, because that is going to change a little bit for each of the different steviosides. What is critical for you to know is that it is only the stevia glycoside purified preparations that have been internationally accepted, because the safety that is supporting the use of these is based on the purified forms. Sucralose, again, we use so little that the very little use, we use so little because it's so sweet, and again, no report of users exceeding it. So just kind of to look at, people say, well, how much can I eat? You know, how many packets? And when we look at how much of these sweeteners are typically used in either the packet that we add to our coffee or to a beverage that we find on the marketplace, you can see that the number of servings, you need to use 80 of those packets in your coffee in order to exceed that daily intake. So it's really no surprise that we have people, not many people, well, nobody is consuming that amount. So, you know, and obviously one of the advantages now is that there are different products out there that are containing different mixtures. So it is even more unlikely that you're going to get too much, because we are often consuming a variety of the different sweeteners. Okay, well, that's all very good, you say, but that's not what I've heard about these sweeteners. So really, what's out there on the, and one of, you know, the big challenges is the internet. The biggest question that I always get is, does aspartame cause cancer? And I have had people come to me when I'm drinking a diet soda and say, you're supposed to be a toxicologist and you are drinking that? Don't you know about that? So don't worry, I know about aspartame. I will talk a little bit more, but aspartame is, to me, amazing in that it is by far the most studied sweetener, the most studied food additive that we have globally, anywhere. And yet, it is one that still, the safety is questioned. So there have been 16 animal studies, long-term, not just short ones. There's actually hundreds of short-term studies overall. But of the long-term ones, 16 different animals, different doses, 14 consistently found no effect of cancer by aspartame. However, in 2005, there is a group from Italy led by Dr. Seguridad who published a report saying aspartame causes cancer. And he has published 2 long-term studies on this. When those results came out, every regulatory authority around the world and many independent toxicologists, such as myself, stopped and said, we need to look very carefully at this. If aspartame really is causing cancer, we have a problem because it is widely used. So every agency looked very carefully at this information, required data to be submitted, and went through it all. And I can tell you, I'm going to show you just one of the pieces of data, but across the board, every agency agreed the methods that they used are not acceptable based on what are internationally accepted methods of testing. Their data were consistently not found to be reliable. Many problems with how they did the study and how they reported the results. So consistently, every agency, and you can read the reports from every agency, and we did a very major review of this work that was published. It's 100 pages long, so it's kind of a lot of boring reading for most people. But consistently, aspartame does not cause cancer. So where does this, how can we still see this? So this was the data they published. They said aspartame causes cancer in female rats. So this is the control, gave no aspartame. And then this is the low dose. This is all in terms of milligrams per kilogram in the diet. And you see all the way up here to 100,000 parts per million. That's 10% of the diet as aspartame. You and I would gag. We could not have something so sweet. So what do you see? Well, you see here that the number, their allegation is that the number of cancers are increasing in the female rat, which is the hatched bar. But look at this carefully then. Where really is there a difference between the males and the females? It's there. It's in the control group, in the ones that had nothing. If the females were the same as the males, in the control group, there'd be no dose response at all. So really, the results are based on the differences in the background incidence in this experiment, which is not typical for these animals. These animals normally should have no sex difference between the background incidence. The other thing is, this really is not much of a dose response. If this truly was a carcinogen and you gave it at 10% of the diet, this would be way up here somewhere. It would not be this little gradual slope with this dramatic change in dose. So really, there is no dose response. This group has a big problem with high rates of infection. So in some of the groups, 94% of the animals were very sick with a lung infection that leads to some of these tumors. So it was too confounding. The results you cannot make clear sense from this report, and it is really unethical to come out and say this study shows that aspartame causes cancer, because it is not convincing. Okay, so I'm kind of going to run out of time here, so I'll move along. Epidemiological studies have also been done because, yes, okay, we can look at animals, but we also like to look post-market, what's happening. And the first study came out in '96 that said the incidence of brain tumors has increased since aspartame came onto the market. They didn't do any measurement. They couldn't tell whether the people that had a brain tumor actually consumed aspartame. So it was just this look at the number of brain tumors before and after in a few of the several locations, and this is the hypothesis. This resulted in, as you can see, many subsequent careful studies that looking for this association and trying to see whether or not aspartame did cause brain tumors. And consistently, when they looked at, do people actually consume sweeteners, then there is no relationship. And this has also occurred again in 2006 after that Safridi paper. Then they looked at the kinds of tumors that were reported there, and again, no association was found. The problem is, you know, we can take some comfort in those epidemiological studies, but truly you only can prove sort of cause and effect when you do randomized clinical trials. It is very, very difficult to isolate the association of one ingredient by doing these kinds of cohort studies. And there are specific guidelines available for assessing the quality of different studies. And this is important and sometimes confounding because there can be small changes reported in relative risk, and even though it's statistically significant, the question is it biologically relevant? And this is a good point to focus on with this recent study that was just published from Harvard University. And so, of course, it creates great interest coming from such a reputable institution. And they looked at 2 of their cohorts. So these 2 populations have been followed for about 20 years, looking at what do they eat through a dietary assessment once a year, and then what diseases do they get. So their first statement is that there is no significant association between the intake of these 2 types of cancers and soda intake. They looked at both diet soda and sugar-sweetened soda. However, when they looked at men, they are reporting that those that drank greater than 1 diet soda per day, which is now we're talking about 180 milligrams of aspartame, increase the risk only in men, not in women. And they may say that this is biologically plausible because of formaldehyde. However, then it got a little complicated because they also somehow saw increased risk in consumption of those that drank regular sweetened soda, but in men, but not women. And this has caused a huge outcry in the press, and you will see different sort of allegations. One, bad science from Harvard, because actually the Harvard press withdrew the press release once they started really looking at the study. However, other studies or other web pages are saying best study ever done shows aspartame causes cancer. So it gets to be, you know, really looking at it. So let's look at the very basis of their idea that, okay, this is due to formaldehyde. Formaldehyde is everywhere. It is in the air we are breathing right now. It is in the air when we step outside the building. It comes from automobile exhaust, from bottled water, treated water, groundwater, high concentrations in tobacco smoke. If anybody put on cosmetics today, there's a possibility it was in your cosmetics, and in many foods. If anybody had a cup of coffee today, there was formaldehyde in your coffee. So, why are we worried about formaldehyde? Because we know that if it is in the gas, it is a gas in the air, and we breathe that at high concentrations day in, day out, there can be problems in terms of irritation of the nose and of the throat. And so for some occupations, those that are in makers of building construction materials, the medical professions such as pathologists that deal with formaldehyde can have some evidence of irritation and increased incidence of cancer in the nose and throat because of the direct irritation. So it has been labeled as a human carcinogen. This is very, very different type of exposure from when it is in food and brought into the liver for rapid metabolism. So the WHO has looked at this very carefully because formaldehyde is used in water treatment and disinfectant. It's a critical question. And they have shown that it is, when it is an oral exposure, there is no evidence for cancer. So, you know, Harvard saying this is plausible because formaldehyde is a carcinogen is, again, an irresponsible way of communicating their results, because that is not true for the exposure method they are using. Thank you.